Global Engineering 276 and 2760. I'm Amos Winter. I'm a professor of mechanical engineering here. And I run a research group called the Global Engineering and Research Lab. You'll notice there's a lot of people in this room. Probably more people than can take this course. Well, definitely. We're going to have to cut the enrollment down to 42. And so I'm going to go over how we're going to do that. But for any of you who are juniors, are you a senior? Yeah, you're a senior, okay. So juniors, I can't offer the class to you this year. You'll have to wait till you're a senior. For seniors, we'll be able to take about 10 people, and then the rest is all gonna be grad students. But I'll cover how we're gonna do that in a bit more, a bit later. So anyway, today I wanna give you a rundown of what this course covers. Already people are you a junior? Are you a junior? Oh, see ya. See you next year. Cool. Alex, you got a seat if you want. All right, cool. So let's go ahead and get started. Here's all the requisite information about the course, my contact information, our fearless, windswept TA, Michael Bookman, who's over on the right. Our course administrators, Kaki Hogan, who's just in this hallway, right down a few rows. You don't need to take pictures. I'm going to post all these on the Stellar site. So you're going to have the slide deck and the video to refer back to if you want. Hey, David. Okay, and then we have 7 project mentors, one for each of the project teams, and their information's there. All this information you can always get at our course website. You might want to write that down, but you can always Google MIT Stellar and navigate your way to this course number 276. Okay, so to start out, why run a whole course on engineering for developing and emerging markets? Why is this an interesting space to think about? And I think there's a few reasons that make it really unique and interesting. The first is that there's a number of unsolved global challenges in developing and emerging markets. And so as a starting set of metrics, we can look at something like the United Nations Millennium Development Goals. And these were set up in the year 2000. They're all metrics of like healthy and well-being for people around the world. And these goals were supposed to have been met by 2015. And about half of them are met and half are not. But even meeting the goals only means addressing 50% of the population that faces these challenges. But I think what's interesting for us as engineers is if we look at this through an engineering lens, many of these have an engineering or technical bent to them. You know, so you can think about new technologies to eradicate poverty, which relate to irrigation and crop growth. You know, maternal care, there's all sorts of health technologies to do that. So this makes it really exciting for me to work in this space because as an engineer, I see, wow, we have skills to address these global challenges. The second point is that people in developing and emerging markets may have very different lifestyles and needs compared to people who grew up in the West. So did anybody go and collect their own cooking fuel from a forest this morning? You know, this is not what probably any of us did. You know, when you look at a device like a tractor in the developing world, 50% of the time it's used is for stuff other than farming. And if you're an engineer designing tractors, you should probably know that. Because like if a guy's going to stack 16 people on it or tow cars out of a ditch or something, you know, you should know those usage practices. You would get arrested if you did this in the US, right? This is blatantly illegal for a number of reasons. But it's, you know, anybody who's traveled to developing countries, this is totally normal. That's a family car. Sahil's like, damn right. He's from Tanzania and he's Indian. So he's seen all this. And then the final point that's really exciting to me is there's multi-market opportunities for designing technologies in this space. So if you can design very high performance, low cost technologies, you might be able to sell them both in emerging markets and in wealthier markets. And this is really a core tenet of what my research group tries to do. And we're going to look at some really nice cases of this during the semester. One is the ultrasound machine that GE Healthcare made. So this is a picture of a Western style ultrasound machine. It costs about $100,000. And GE was trying to engage the Chinese market to sell their equipment. And they quickly realized that if they tried to sell these devices, only the richest hospitals would buy them, and there's no way they would penetrate the market, and a domestic firm would just take over the market. And the really clever thing that they realized is that the Chinese market was willing to accept a reduction in performance compared to what you get with this guy, but they would only pay 15% the price. So they realized 50% the performance at 15% the price would sell, and that's what they ended up making. This is a low-cost ultrasound machine, and they are now the biggest medical device supplier in China, actually located in China, and this thing sold like hotcakes throughout the world. But I love those, like, if you can get that insight and figure out that high-value, low-cost, high-performance solution for developing countries, it may work globally. And then there's other examples where people just rethought how you deliver a product in different countries. And so a good example there is shampoo. So the big-ass Costco-sized bottles of shampoo that we buy just don't sell in developing countries because they're too expensive, and your cousins will come over and take them, and And so what P&G and others figured out is that people would buy single-serving shampoo sachets, like ketchup packets. And so there's as much shampoo sold by volume now in developing countries as there is in rich countries, and it's because of this packaging difference. The product's the same. Right? So I think that's really clever. I think that's really exciting to see how the unique socioeconomics of these markets influence the engineering decisions that were made. Also, I think in a lot of developing world technology courses that you'll find around US universities, when you think of developing country context, you often think of this. Poor people out in a rural area using kind of rudimentary old technology. But that's not true, because emerging markets also means this, right? It means there's 1 billion plus middle-class consumers that weren't there a generation ago. And these people buy a lot of crap. And people make a lot of money selling that crap, right? And we can figure out how to make things that these people want to buy. And so just a few indicators, like China and India have been very rapidly growing economies over the last few years, right? And they're going to be the biggest in the world for quite some time. And then the global market capital of emerging markets is growing massively, right? And so, a few years ago, this study was done in 2010. The BRIC economies, which stands for Brazil, Russia, India, and China, but it's kind of the acronym used for all emerging markets. Only 18% of global market capital now, and 41% in a few years. That's crazy. So all the major economic growth that's happening in the world is happening in emerging markets. And we as designers need to tap into that. So the question we're going to explore in this class is, how do we do that? How do we understand the unique socioeconomic factors of these markets and understand how it influences us as engineers? So this class builds on what my research group does. We're called the Global Engineering and Research Lab, and we go by the acronym GEAR Lab. And what we do is we try to characterize the unique technical and socioeconomic factors in global markets, and then we use machine design and product design research to create these high-performance, low-cost technologies that are globally relevant, right? And so my main areas of work are around water, mobility and assistive devices, and agriculture. And so one thing I find so fascinating about when you start addressing these challenges is that, and this is something we do in our group, and we're going to do in this class too. Come on in, we got a lot of people, but you can find something to perch on, I guess. There's a step over there if you want to sit on it. Okay. There's not a seat, there's a step. Yeah, so what I think is really interesting about working in this space is that when you start looking at these challenges, they're by and large challenges that have already been solved in rich countries, right? Like we have water and sanitation services in this country. We have very effective agricultural technologies. And so the problems that emerging markets are facing have been solved here. But the issue is that when you look at a family of technologies that can solve technical challenges, there's going to be a range in the performance the technologies provide versus their price. And so, you can have your Ferrari solution up here and your Toyota Corolla solution down here, right? And the real crux of the problem that we see time and time again is that emerging markets and developing countries demand performance similar to what we have in this country, but the price point is a lot lower than they can afford. Right? It's not like you can go to a developing country and be like, hey, are you cool with drinking dirty water? Literally like drinking your own excrement sometimes? You all right with that just because you're poor? No. Like people don't want to do that. They want clean water, they want good health care, they want low infant mortality rates, all the stuff that we have, but the price points are different. And what's interesting about this is because this intersection of lines lies off what existing technology can provide, we find often there's no solution. We can't just adapt an existing solution. We have to create a disruptive solution. And I think this is a very exciting area for academics to work in, to do the hardcore science and engineering that can make this leap, right? And so once you make that leap, then you can think about, wait a second, I can create a new family of technologies and move up a new curve, align with the price points of wealthier markets, and create reverse innovations, right? Global product platforms. And so this is what my group is doing. And so we've done it now with a wheelchair, and I'm going to do a case study on this so you hear all about it. We're doing it with desalination and irrigation systems. This is an off-grid electrodialysis desalination system that we just won a big USAID prize with, and I'll tell you more about that this semester. We're doing it with prosthetic limbs. This is one of my grad students doing tweaking a high-performance, low-cost prosthetic knee that's designed to replicate normal, able-bodied motion. And then we're doing it with power systems, and this is Michael's research right here. This is a single-cylinder, turbocharged diesel generator. And we're actually going to be adapting this technology into scooters this semester with a scooter company. That's one of the projects. So that's going to be pretty fun. So I'm a total gearhead, right? Gear. Like, I like making things, and our group makes hardware. And in this class, you're going to make hardware. So I hope you like doing that. It's fun. Okay, so I want you guys to think about, like, going into this class, and I think going into your careers, what type of engineer you're going to be, right? Are you going to be this type, like Dilbert? You know, sitting in his tiny cubicle, he's the king of the cubicle. Like, the era of fat white guys sitting out in a cubicle in Ohio designing products for the world, that's not happening anymore, right? Like, what context, and this is Milton from Office Space for you Office Space fans, you know, what context are these guys going to have about the local needs of, like, a poor farmer in Indonesia, right? This guy has no cultural connection to them. So how is he supposed to sit back and design technologies from a cubicle? You know, are you going to be the type of engineer like this? The great white savior that delivers solutions to the poor brown people around the world. You know, that's like, you know, Angelina Jolie does a lot of stuff. I just, you know, I'm picking on her a little bit because of what this picture looks like, right? Big smiling face, giving the thing over. And you know, you see so many charitable organizations that are really self-serving. You know, they want to feel good about helping out poor people, and you know, the impact is more on them than on the community. And I'm going to try to make you guys think broader and say, where is my best value added in this space? How can I impact these people? How can I work with them? These people are really smart, right? And they know a lot more about their own lives than we ever will. You know? Another one is, I don't want you guys to be this type of engineer. And I think, how many of you did Engineers Without Borders? Okay. No, it's a really good program, but I think the impact is primarily on the students, right? What they do really well is they have a 5-year commitment with a village. You know, they don't just swoop in and leave. But the thing is, like, after 5 years, if you've only impacted one village but spent tens of thousands of dollars in travel, that's not a scalable and sustainable economic model, right? So I think, like, an engineer like me, who has a doctorate in mechanical engineering from MIT, it doesn't make sense to ship this fat gringo halfway across the world to dig a ditch, right? You can hire local labor to do that really well. What it makes sense for us to do is think of crazy new technologies and use the research and innovation muscle at MIT to come up with disruptive solutions, right? That's where I think our real value added is here, right? And where your value added. And actually, by the way, all your class projects are built around that idea. We're working with organizations that have great experience and great market knowledge of their home markets, but they're missing a technical capability. And that's what we're filling in. You know, you guys are basically consultants for these organizations. Cool. So yeah, I want you to think about this idea of what your value added is in this space. And I like these two pictures from us doing our research, because, like, in this first one, you know, you've got this guy clearly with a prosthetic limb, and he's talking to my nerdy grad student with his notebook and his collar, you know, and this guy doesn't know what it's like to live every day with a prosthetic limb. But this guy does. He does it every day. He knows way more about it than we ever will. But this guy's a ninja at dynamics, in figuring out biomechanics of prosthetic limbs. And he came up with a really fundamental insight of how to make prosthetic knees move with able-bodied motion with a purely mechanical system. Right? And it's that exchange of information that's so valuable and that I want you guys to learn in this course, interacting with your partners. The same is happening in this picture. We're in a cotton farm here. This is one of Pekko Hossoy's grad students, Pavel Zimoch, who worked with me for a while. This is one of the head engineers for one of the biggest drip irrigation companies in the world. And this is the cotton farmer. And we're having a conversation about growing cotton with drip irrigation. That's pretty cool to have all that information and those perspectives swirling around. Instead of us sitting back in our lab trying to come up with a technology and then going over to India and trying to implement it. Okay, so what I want you to get out of this course at the end is a perspective on the technical and socioeconomic factors of emerging markets and how you can leverage your engineering skills and technical skills in these new markets. You guys are all highly trained engineers. Crazy ninjas of technology, right? And if you can put those skills into context, you can make really profound contributions to developing and emerging markets. Some other things about this class, and I'm going to go now through elements of the class. This is one of our quals prep classes for both the machine and product design qualifying exams. I would recommend that you take this class and 272 if you're going to do machine design, or and 2744 if you're going to do product design. But this class teaches you an approach and an analytical kind of mindset that's very relevant for both of those qualifying exams. The type of projects you're going to do and examples and product teardowns and stuff are very much in line with our qualifying exams. So it will help you. Okay, now, what skills are needed specifically for doing this type of engineering work? And I think there's a few core skills to talk about. The first is defining design requirements accurately, right? This is where I think a lot of developing world technology goes wrong. They have brilliant ideas, but they just don't frame them correctly in the market space. So, for example, this is a product called the Life Straw, and this is a brilliant idea. No bones about that. It's a portable water purifier. It was made for populations that often drink from surface water like this and face biological contaminants. It could take out I can't remember the name of the worm that these people would drink sometimes, but it will take that out. It's cheap, really, really brilliant idea, right? But how do you feel about this picture when I put this picture next to it? Right? It's a little disturbing. And so this product is degrading. Like this, if you think about this woman sitting in a puddle, getting dirty and wet, that may have very negative cultural ramifications in her village, in her society, right? And that might prevent the technology from being adopted, even if it works technically perfectly, right? And so we should try not to make those type of mistakes. We should try to realize, hey, this might be degrading. I see this in prosthetic limbs all the time. So you see wounded veterans in this country showing off their RoboCop style, amazing technology limbs. They'll walk around in shorts, and it's really impressive. That never happens in developing countries. People want to be incognito completely. Even down to the sound. They don't want the knees or anything to click, right? And it's just such a big cultural difference, but it changes what you do as an engineer. The second is understand market dynamics that are unique to these countries. So in this picture, what is this a picture of? It's a slum, right? If any of you have flown into a city like Mumbai, you'll look around and you'll see just acres of this stuff. But what do you see on all these houses? Satellite dishes, right? And it's not like people are eating the satellite dish, right? This is a luxury type product, but it's valued enough, and probably more so than house renovations, that people will buy it. And so when people, one of the themes in development technology you hear a lot is let's make a $300 house. Well, that's really neat, but then you have to ask, who's going to buy the $300 house? Who's going to value that house enough to fork out $300, which might be close to a year's salary? Whereas people might fork out $100 or $200 for a satellite dish, there's instant gratification out of that. Right? And if we can understand those preferences and what people want, and maybe align what they want with what can benefit their lives, you might be a better and more successful product engineer. Another point is thinking about the entire ecosystem of stakeholders that might be around a technology. I think a lot of, like, you guys have probably heard the term user-centered design, human-centered design. Those ideas really focus on the end users, which is great. But typically with products in any markets, there's a whole chain of stakeholders that you have to satisfy the needs for a product to be successful. So you certainly have to think about a guy like the end user, but you might have to think about manufacturing distribution. And you might have to think about the executives' needs of, like, meeting quarterly, profits and stuff. All of these guys are going to impose constraints and requirements on a product. So if you can understand those, you can design better. And the final is this idea of reverse innovation that I will keep hitting on, that, like, you design a high performance, low cost product, you can possibly sell it in global markets. And so this is a version of our wheelchair made in India and one made in Cambridge that we sell in the US market. And I'll tell you more about that in a few lectures about how this thing came to be. Okay, so lectures in this class. We're going to talk about design process. We're going to take kind of a machine design perspective, and by that I mean a bottom-up perspective. We break a big complex system down to small parts, work out all the parts, build them up together. And then we're also going to think about a product design perspective, where you have to think about the thing in its final embodiment and how a user would interact with it. So you guys are going to have to be shifting between this top-down, bottom-up work, and also you're going to be working with stakeholders through your partners on your projects. We're going to look at technology both through that product and machine design lens. We're going to understand socioeconomic factors and how they impact engineering. That's going to be a theme you'll see a lot in your projects and in the exercises we do in the class. This is a graduate level machine design course, so we're going to dive into the physics of a lot of things. And in your projects, you're really going to dive into the physics because you're going to be making new technology. And then we're going to do this thing that I refer to as the engineer's toolbox. And I'm going to try to give you a number of examples where we'll use common engineering approaches and tools to solve problems. Like conservation of momentum, conservation of power, things like that, free body diagrams, all that good stuff. And so we'll do those in class exercises and, of course, your projects too. We're going to do a bunch of case studies in this course. We're going to look at lots of different technologies. So, this is the Super Cub, Honda Super Cub, most produced vehicle ever in history, the Jaipur Foot. We're going to have a guest lecture on the Kalashnikov, the AK-47 assault rifle. Yeah. Do you know how many of these have been sold? 175 million. One of the top disseminated, like, complex products ever in developing countries. And I'm not trying to laud its killing power, but there's a lot to learn there as engineers. Like, why is this product so widely disseminated? I'm going to talk about our wheelchair that we designed, and then some other products like the low-cost ultrasound machine. And that's the cell phone that really opened up emerging markets. That's the Nokia 1100 cell phone with a flashlight on top. We're also going to do demos. And you're going to play with these products and test them and think about them from the user perspective and the engineer's perspective. So one of them we're going to do is working on cook stoves, and we're going to see the efficacy and efficiency of different cook stoves. And then we're also going to play with treadle pumps. Have you guys seen these before? They're like Stairmasters for water pumping. So you guys are actually going to test this and measure the power output. We're also going to do teardowns of real products in emerging markets. So you can tear them apart, think about what the engineer and designer was thinking when they designed it, work out the basic physics behind it. And one of the products, are we going to do the swatch, Michael? Do we have an extra swatch? Okay, yeah, we'll do a swatch. So I want to show you a commercial from the Tata Swatch. This was a water purifier created in India primarily for poor segments of the market, people who live off the electrical grid and face biological contaminants in their water. So I want you to watch this commercial for this product.
छिटको को चांदी के चम्मच से पानी पिलाया। बोलो क्यों? क्योंकि छिटको को प्यास लगी है। अरे नहीं, क्योंकि चाचू को दूसरा कोई काम ही नहीं है।
क्योंकि चांदी करती है पानी को स्वच्छ, और स्वच्छ पानी पीकर छुटकू रहेगा स्वच्छ।
चांदी की इसी क्षमता को और भी बेहतर किया है टाटा स्वच्छ के अत्याधुनिक नैनो टेक्नोलॉजी ने। ये छोटे से छोटे कीटाणु को मारे और दे आपको पानी जो हो सचमुच स्वच्छ।
ये नए जमाने की चांदी है जो सचमुच स्वच्छ पानी देती है।
टाटा स्वच्छ।
So what'd you pick up in there of like cultural specific like cues in that commercial? What'd you guys see? A child. Okay, what about the child? No. To protect your child. Yeah, I think that's good. Yeah. What'd you see?
Also, like you don't give children that age the same water that you would give other children. Like a lot of parents give them distilled water, so maybe the water quality is somewhat higher than even water you would drink otherwise.
I don't know. I don't know if people really distinguish between the water they give. I think the other guy's comment is closer, that you want to protect your children, right? That you're providing clean water to your children. There's a bunch of other stuff. What'd you see? A little bit of that. Yeah. Yeah.
There's a lot of value on technology, like they said, nanotechnology, and they spent a few seconds on that.
Buzzwords. There's another thing around that. Did anybody pick it up? Silver nanoparticles. Yeah. The silver part, right? This is marketed in India, where precious metals are like a big thing, right? They definitely play up the silver aspect. Yeah.
That they tied in the old tradition of feeding your child with a silver spoon.
Oh, really?
Silver nanoparticles in the purified powder.
That's cool. I didn't pick up on that, but I think you're right. Anything else? Yeah.
I was thinking that if it's marketed towards poor families that are off the grid, that seems like a very middle class, very
Yeah, like higher than that. Yeah. Yeah.
upper class, whatever it is, so maybe they're saying it's good enough for rich people to use.
Hugely aspirational, right? You've got the light-skinned family. They're all attractive. Like, it's really an aspirational product. One more that I saw is that it said like a 10 or 100 crore bacteria reduction, right? And crore is a unit of 100,000. Yeah. It's 10. Yeah. So it's a number that I screwed it up. It's a number we don't use in the West, but it's instead of doing like a log 10 reduction or something, they instead said the absolute number in the local way of counting things, right? So I think there's so many brilliant marketing things going on in that commercial. It's really cool. So that's the kind of stuff we're going to do, is look at things like that. We have 4 required texts that you're going to read from. And by the way, the beginning of the class is more reading heavy because you're not really up to speed building your projects yet, and then it shifts over to being much more project heavy. So just keep in mind that the 12 hours a week for the course is going to be pretty consistent throughout the semester. All these books are available in the Coop. I put them on reserve. You can probably get them cheaper off Amazon, and as students you can get free Amazon Prime, so you can get them in a couple days. And we're not going to have any book reading assignments given until after we figure out the project teams. So, if you're thinking that you might not get in the class or something, you can wait to buy the book and you won't be behind on reading if you do that. Another 2 texts that I highly recommend just as mechanical engineers, these are great references to put on your bookshelf in your office, is Shigley and Mischke's Mechanical Design and Mark's Standard Handbook for Engineers. This has all sorts of common machine design calculations and equations in it. They use gears, bearings, fatigue, all that stuff. And this is just a general encyclopedia of engineering stuff. If you want to know like the minor loss coefficient of like air conditioning vents, it'll have that, right? It's a really, really good resource. But these aren't required readings for the class. We're also going to have a bunch of guest lecturers. And the guest speakers that I try to bring into this course are people that work in fields that are certainly tangential to ours as engineers. And they may not be engineers themselves, but the work they do can greatly influence what we're doing. And so the first guy is going to be Abhijit Banerjee, who's a professor here, and he's the author of one of the books you're going to read. But this guy studies the economics of poor people in poor countries. And there's a great line in this book where they're interviewing a guy, and he says, TV is more valuable to me than food. Right? I prioritize it so much higher because I get that return, and it's what's entertaining. And like those type of product insights and consumer habit insights, like even though it's being done in economics research, influences what we do as engineers. Right? If we can understand what a consumer is going to value and want, we can design it for their wants as well as their needs. Another one, and we're still finalizing this, so but I think it should happen, is Dave Ferguson, who's a director in the USAID Global Development Lab. This is a new program that started about a year and a half ago at USAID, and they're trying to be the DARPA for development. Do you know DARPA, the Advanced Research Projects Agency of the Department of Defense? So these guys are dumping lots of money into hardcore R&D of disruptive development technologies. And this is a great connection to have if you move into this space as a career. We just won an award with them with our decel stuff, and it's opened up huge doors throughout USAID's offices around the world, as well as like the UN, UNICEF. So really, really great connection. And he'll have a great insight about how academics and students like you guys can impact global development. The next is Ratan Tata. So this guy's like, I don't know how to describe him. He's kind of like the Tony Stark of India. Like he's an amazing guy. He grew the Tata Group from a big company in India to a massive global juggernaut. You know, they own Jaguar and Land Rover and over 100 different companies. He retired a few years ago, and now he runs the Tata Trust. But he's going to be at MIT in October. And we might have to hold his session outside of our normal class time, but I'll keep you posted on that. But he's come to our class the last 2 years, and he's really awesome to speak to. Like, you know, as far as like juggernauts of industry in emerging markets, he's the guy. We're also going to have a professor, a colleague of mine, Chris Matson, and he's really one of the leading academics, I would say, really promoting research in global development. You know, how engineers can do research in this space. He's an associate editor of the Journal of Mechanical Design, so those mechanical engineers in here, you might be publishing there. And he also coordinates one of the programs at the IDETC conference, which is the main design-focused conference of the American Society of Mechanical Engineers, where we send papers from this class, actually. We had one of our papers from the class in that session. We had a bunch of other papers in that conference. But he's got some really, really good perspectives on global development. We're also going to have Shashi Bolaswar coming, and Shashi runs an organization at Lawrence Berkeley National Labs called LIGHT. And what they did that is so awesome is they did this big few-year-long survey of what the 50 biggest breakthroughs that have to happen are in developing countries, technological breakthroughs to really change people's lives, right? They didn't just say like, we need to make clean water. They said, we need off-grid desalination systems that cost this much and have this throughput. They really did their homework to figure out a lot of the quantitative metrics that would determine success and really lay out this like, I don't know, these awesome targets for us engineers to go after. Like, their report is such a great starting point for engineers like us to look like, hey, I work on desalination technology, maybe I could help in this space. So, really, really great guy. And then at the end of the semester, Bob Hawk is going to come, and he's the chief mechanical engineer, whoops, not mechanical engineering, chief mechanical engineer of GE Healthcare. So GE Healthcare is arguably the most successful Western firm in designing products for emerging markets specifically. They have rocked it with their low-cost ultrasound machine and EKG machine. And this guy, like his position as chief mechanical engineer is he's like the wizard for GE. Like he goes in and solves the unsolvable problems. So what we have him do is come to this class like a week or two before your final presentations and give each team feedback, right? So you're getting to consult with the Pope of engineering, you know, before your final presentation. So it's pretty awesome that he comes to the class. Okay, so team projects in the class. Each team's going to be composed of 6 students plus a mentor who's going to work with you. Your expected deliverable at the end of the class is some sort of proof of concept prototype or analysis. It may be purely analytical, but you need to provide the theory and engineering rigor to show your work. You know, you don't just cobble something together, you make good engineering decisions. Each team has a $5,000 budget. All the purchasing this year is going to go through my administrator, Kaki Hogan. And the way that's going to work is that we're going to have an online Google Docs spreadsheet for each team. You're going to plug in what stuff you want to buy. She's going to make orders like twice a week, but if you need something ASAP, you just ping her an email, she'll order it that day. And then it'll be sent to her office, which is right in this hall, and you'll pick it up. You're going to have 3 milestone presentations. We used to have 4, actually, and we got really good feedback in last year's class that the first 2 really could be combined because you're finding your way in the beginning of the course, and by doing the first two combined, you have more time for the second two. Each of these is a month apart, which I think is really good timing. It actually gives you a bit more time for the later stages. So you're going to talk about the strategy and a concept for your project. Then you're going to present your most critical module, which is that keystone of your idea that's going to make or break it, and then your final prototype. It's really important to remember that you're going to design with your partners, not for them. And the more exchange of information you can do, the better. And all this information is written out in our course information document, which is on Stellar. And by the way, we have built into this class costs a fortune to run, by the way. We have, thank God for the Tata Center here, but our industry partners are contributing more and more. But anyway, we have money for each team to send a representative to their partner during IAP. And this is awesome because it really closes the loop of the projects. You get to bring your prototypes, you get to bring your presentations, you get to walk through step by step with them, and this is such a good way to transfer information back to the partner. Every team's going to be required to do their final presentation through Skype or WebEx to their partner, and so you get some exchange there, but nothing beats face-to-face. So we intentionally build this in. Plus, there's a lot of other opportunities for you guys to travel, and we'll have somebody come in and talk about those. But through the Public Service Center here, Misty has provided money for us. So if you want to travel during IP, there's ways to do it. I'm going to give you a really short rundown of the class projects, and then next class I'm going to give you more details about them. But this is just a one-slide rundown so you can see if these projects are exciting to you. So the first is working on the engine system of the Tata Nano to reduce noise, vibration, and harshness. And I'll tell you more about that next class. But what's sweet about this project is we have 2 Tata Nanos. Right? They're parked out behind my lab. So you have a third engine. Michael and I ripped out the engine of our third Nano, which had to get crushed last year because it had been in the US too long. These are non-compliant vehicles for safety and emissions. So they're on temporary visas basically in the US. And if they stay too long, they get executed. So we had to crush one. We had a yellow one. But we saved its engine. So those of you working on this project, you can take apart that engine, make new mufflers, whatever you want. The next one is working with one of the biggest eye care centers in the world, LV Prasad, to make a single device that can both do short and long distance magnification. So imagine you're a kid in a classroom and you want to be taking notes and seeing your notes and then look up and see far away and see a chalkboard. There's not really a low cost device able to do that. And last year we had a team in this course that made a lot of good progress on this. They put together a starting architecture, they did some looks-like models, and this year's team is going to do the full integration of this technology, like actually making a piece of hardware, you know. So this will be really cool. And the doctors at this eye care institution are fantastic. They're really great to work with. The next one is these guys, Ferrari. So what Ferrari's thinking is down the road they're going to have to hybridize their vehicles because of emissions requirements. They face them just like any other car company. And this is a picture of their current transmission. It weighs something like, do you know, Michael, it's like 400 pounds? 300 to 400 pounds. This thing is a lump of metal. This is in my lab too. You can go play with this. Don't drop it on your foot. So anyway, they want to hybridize the transmission and do it in a way that they can package it in this package for the same weight and about the same cost. And last year we had a team do a conceptual architecture for a new transmission. They used 2 electric motors, and this is a picture of their concept. Ferrari this year wants us to try to do it with 1 electric motor. So it's a whole new offshoot of solution space. And these guys are also fantastic to work with. Like, you know, the typical, like, really passionate, you know, engineers. They're a lot of fun. Okay, the next one is working with a community health organization based in Haiti that has some off-grid, really out in the middle of nowhere villages that have salty groundwater. And they want a low-cost desalination system. And the cheapest one we can make right now, we're also working on desalination in our group, but it's a few years away from commercialization. Cheapest way to do it now is with reverse osmosis. And the systems at this size scale are really like only made for boats and yachts, so they're really expensive. So we're going to design a full system, full photovoltaic powered reverse osmosis system. So you're going to like build a little desal plant in this project, which would be pretty cool. The next one is working on liquid desiccant cooling for air cooling in hot countries. So here's a bunch of air conditioners on the back of an apartment building. Air conditioners put a huge grid load on the electrical grid, and in emerging markets we're getting more and more middle class people that want to be cool and buying these things. It's more and more energy consumption. On the other end of the spectrum, a ceiling fan uses basically no power in comparison, like order of magnitude less power. And what could be a nice in-between that could provide cooling of air conditioning but with less power is liquid desiccant cooling. And it's a means of like removing water from the air and cooling it down kind of in two separate steps, rather than really overcooling it to condense the water and then warming it back up that an air conditioner does, which takes more energy. So we did a feasibility study on this in last year's class, but this year we're going to make one of these suckers. So that's going to be the project with these guys. And Usha is a huge consumer products manufacturer in India. They sell millions and millions of ceiling fans every year. The next one is a mechanized cotton picking system with Mahindra. Mahindra is the largest tractor manufacturer in the world in a massive agro business in India. So this is how cotton is picked now in India. It's by hand. This is how cotton's picked in the US. We want to make something in between that can pick cotton at about 3 times faster than you can by hand. So, picture something maybe like this, right? Dustbuster, where you can suck off cotton. So this is a really neat mechanical problem, how to extract the fibers from the plant without like sucking up the rest of the plant, but still leveraging people's dexterity, right? That's why people pick cotton by hand, because they can reach around things and get all the fibers out. So that'll be fun. And then I think this is the 7th project. The last one is working with Peugeot Scooters, big scooter manufacturer in the world. And they make 50cc scooters because under 50 cc's you don't need a license or registration to ride them. But because of new Euro emissions, they can't use 2-stroke engines anymore. They have to use 4 strokes, and they lose power by doing that. So we have a technology we've been working in our lab, Michael specifically, who's going to be the mentor for this, which enables a single-cylinder engine to be turbocharged. And I'll talk more about this during the semester, how this works, but it's just a little simple can we include in the intake manifold called an air capacitor, and it enables a single cylinder to benefit from turbocharging. We haven't tested this on a gasoline engine yet. This will be our first time. So this is a really cool new frontier for this technology. And by the way, Peugeot's sending us 2 brand new scooters and 2 brand new engines to do this. So that'll get here, I think, end of next week. Yeah, we get cool toys to play with in this class. To give you a bit of perspective of what the projects are like in this course, I'll tell you about 2 from the last 2 years. 2 years ago, we did this project called the Bull Key Traction Project. And Mahindra, which I just told you about, is seeing that there's a massive segment of the market, farmers that farm only an acre or 2, that are currently using pack animals to farm, like oxen, and are not really leveraging mechanization to farm. And they're thinking that they could make maybe a small tractor that the farmers could use in that segment. And their smallest tractor now is this thing. It's called the Yuvraj, and it's 15 horsepower, and it's really only used on farms of greater than 5 acres. So we want to come up with a tractor that can compete with these guys. 1 or 2 bullocks that are used for small acres. And so, what would unlock a bullock? A bull key, right? And that's where the project got its name. It's really cheesy, but we still use it. So anyway, when Mahindra started this project with us, they gave us a bunch of design requirements that they had spec'd out for this new device, right? How much horsepower, how much speed, how much pulling force that they think it could generate given its weight, and then a bunch of other factors that had to be met. And they were really concerned about the traction system. They were concerned that with a tractor this light, could they generate this much traction force, right? So what the team in the class did is they first started with a bunch of market data about tractors. And so you can look at metrics like how much does a tractor weigh versus how much it can pull. You can put a trend line here. And then here's the trend line taken down. And then here's at the device weight that we predicted, this is what they were predicting. This is what they wanted, about 300 kilograms of drawbar. And this is the lower range, right? So we were kind of in between here. We didn't know how much drawbar force they could actually exert. So then the students went into the analysis of traction theory. How much traction can you get with a certain diameter of tire and soil type, etc. They did bench level prototypes. So here's the amount of torque you would actually get on a wheel on a little tractor with also the normal load you could expect of that weight of tractor. And then they actually made a mule, a test mule, a little proof of concept prototype, and measured the traction achievable. And what came out of this is that, I think I wrote it here, yeah, only about 200 kilograms of traction were possible with a 350 kilogram tractor. And when we went back to Mahindra and told them this, they were like, oh my God, you saved us so much R&D time and money. Because what we would have done is we would have made a little tractor from scratch, like a full-out tractor designed, and tested it. And we would only have then realized we could get 200 kilograms of force. Instead, what we did is in one semester, we did all this analysis, and then we made this little test mule that had the correct weight and weight distribution of their new tractor, and showed them, really proved to them that they would be limited in traction force. And so this has now spawned a whole new research project, which actually Guillermo is starting right now in my group, to figure out, how can we make high traction systems with lightweight, low-cost tractors. So, I think one of the special sauces of this class, right, is that we take on projects where, given the constraints that you have being students, so you haven't worked in industry maybe for a long time, and you only have one semester to work on these projects, that the way we set up projects, you can make a big impact on these companies and make a big impact on real products, right, given those constraints. And that's awesome, and the companies love it, and the students love it. Like, this class is turning into a patent mill. We're generating new IP and new ideas that are being patented. So that segues into the next example, last year's Ferrari project. So Ferrari gave us this challenge of thinking about hybrid transmission architectures. And it couldn't weigh more than the current transmission that they use in their higher production volume cars, like the 458. Matches the current performance specs and improves driveline efficiency. And this set up a really harsh competing constraints that we had to up performance and up efficiency, not one or the other. So I like that. I like those type of problems. And Ferrari gave us some designs that they had been thinking of, but the students really took a step back and looked at this with a clean slate and came up with a really innovative new architecture. And I'll quickly walk you through this. Here, it's a little complicated looking at this, but here's the internal combustion engine. Here's one electric motor, which is always connected to the wheels, and another electric motor, which is always connected to the engine. And so with this scenario, what you can do is you can use this motor to start your engine. You can use the engine to charge your batteries. You can drive at the same time, separately drive with this motor versus charge with that one. Or you can combine the power of the electric motors with the IC engine to dump a lot of power to the wheels. And the real merits of this is that with this architecture, we could get rid of the clutch. There was no clutch in this architecture. When we first told Ferrari that, they were like, wait a second, that's blasphemy. Like, you can't have a car without a clutch. And in the great, emphatic Italian way, they were like, no way, this is crazy. And then they came back and thought about it, and they were like, wow, we would have never thought about this because we're a car company and we always think a car needs to have a clutch. But the reason we can get rid of the clutch is that when we want to shift into a gear, here's the transmission, and here's the gears, like 1, 2, 3, 4 gears you'd shift between. When you need to shift into a gear, what you do is use this motor to match the speed between the driveline coming in and the IC engine coming in. Right? So they move at the same speed, and then once they're at the same speed, you click into gear. And then when you want to disengage a gear, you use this motor to bring the torque in the driveline to 0 so you can disengage the gears. And so this is a really novel architecture that we haven't seen patented before. Ferrari's super psyched about it. And we just, we're filing a patent on it. So they're really excited about this because we looked at this from a totally out-of-the-box perspective. And they found a lot of value in this. And this has become a research project in my group, and the project that's going to happen in this class is removing one of these motors and seeing how well you can do. Because this is still an issue of cost and control. And so they want to see, can we do it with one electric motor somehow? Okay, fabrication facilities. As you probably guessed, you're going to be making stuff. You're going to need to seek out your own fabrication facilities, but we've got a ton of them on campus. And in one of our lectures coming up, we are going to go through the MakerWorks training, which is the student-run makerspace at MIT, for all of you. So then you're going to be eligible to use it. So you're going to have lots of maker facilities. Plus we have the hobby shop, Edgerton shop, L&P, grad shop. So if you look around, there's lots of facilities for you. Each team is going to have project space allocated to them as well. In a room located above my research lab, which is right next to the building where the nanos are, if you're working on the nano team. But it's a whole big laboratory classroom that you have allocated to you, tons of tables, and it's filled with shared use tools, power tools, 3D printers, like all kinds of stuff you can use for your projects. That's just for you. That's your space. Michael's here as your fabrication guru, and me, if you need advice. And please, please, please keep it cleaned up. Like, I gotta stress that all the time. Like, class projects are the most notorious for being messy. So please clean up. It's a shared area. Clean up the shops you use. I will keep stressing that. Okay, the final report for this class. We don't have any tests in this class, by the way. You just have the presentations. You have one product teardown that you'll do a short presentation about, and then you have this final paper. And I'll go through the grading in a second, the full thing. But anyway, you'll produce a final report which is going to be formatted for a conference. And most of the papers are for the ASME IDTC conference, but if there's another conference that fits better, you can choose one of those. I have some examples thrown up on our Stellar site. So this is one I did as a graduate student a number of years ago, and I was at the same educational level as you, and it was the same scope as far as the timeline in the fabrication that is what's done in this class. So this will give you a good sense. And then here's another one that's a similar timeline and scope that came out of my research group a few years ago. And then I put a few papers from the last 2 years up there too, from previous class projects. So you can check those out. But your conference paper is going to have, the main sections of like a background and motivation. And so this paper that I'm using as an example was about wheelchairs. So I talked about competing products. I talked about the global market for wheelchairs. So you're going to want to say why your project is valuable. You're going to have to present analysis. Like, what is the engineering you did? What is the optimization? So this was for our lever-powered wheelchair, and we were optimizing lever lengths based on people's power output capability and what sort of terrain they wanted to travel on. Is that Angie? Hey, Angie.
Hi.
Cool. I'm just wrapping up. You're going to have to present materials and methods, talking about the prototypes you made. You're going to have data and results, like validating your hypotheses, showing that your engineering analysis is real. So these are like, what were these? Speed data, and I think, we didn't do pulling force data here, but a speed versus heart rate on for different subjects here that we were testing. And these are all tests that we conducted at MIT. And then a conclusion and broader impact, like why is this work important? How could it be used? And so there's lots of examples on the website, on the Stellar site now for you to check out. So yeah, examples on Stellar. Angie Lochnar, perfect timing. You're the next bullet point. She's going to tell you about resources at the library. So the outputs of the class, I want you to make new technology, and I think a lot of people are going to get IP and a publication, right? Which is great for all of you as students. And think like a global engineer, this like socioeconomic plus technical, how that influences you as an engineer. Here's the breakdown of grading. So I already told you these 3 presentations. Then we have the product take apart, the final report, and then your individual performance is judged on a peer review that you will do within your team, your mentor's feedback, and then a little bit of that added in is your participation in the class. And one thing we added this year is that we're going to do a non-graded peer review at the midpoint in the course. Because like if you're slacking off in your team, you should get the feedback that you're doing that midway through the course instead of at the end when you get slammed, right? So this I think will help a lot this year. Okay, and then your first assignment, I have 2 readings posted right now on the Stellar page under readings. The Human-Centered Design Toolkit, which is a kind of how-to booklet done by IDEO, how to design products for developing countries. And then this article by George Whitesides, who's really an academic like luminary, but this is kind of a call to arms for scientists and engineers to engage in global development. And please also read our course information document. That says in detail about all the aspects of the course, grading, assignments, all that good stuff. So in the next class, I'm going to give you a detailed rundown of all the 7 projects. We're going to talk about how IP is managed in the class and with our partners and all that. We're going to start going through the design process, talking about that. So you notice there's a lot of people in this room, and we can only take 42. 6 people per the 7 teams. What we're going to do is kind of like a draft, right? Each of you is going to fill out a card with your background, with what your expertise is, what you're majoring in, what your degree is here, all that stuff, because we want to do a few things with the class. We want a broad set of experiences for each project team. This is a graduate mechanical engineering course, so the majority of people in the class are going to be graduate mechanical engineers, but we will have about 10 seniors in the course. So if you're a senior, I would recommend that you stay co-enrolled with 2009 in this course for another class and a half. So we're going to do these data cards. They're online. You're going to do them after next class. They have to be finished by midnight on Monday. And then on Tuesday, we're going to work out the project teams and email you. So by Wednesday, you'll know if you're staying in the class or not. And I would say, like, you know, if you're still shopping around, come to the next class and try then to decide if you really want to be in this course or not. Because what I don't want to have happen is we pick people on the project teams and then have to go back to a wait list if people don't want to take the course that we picked. So we're trying to do this as quickly as possible. Cool, good timing. I'm going to have Angie now talk about library resources you have available to you. Are there any quick questions? And by the way, I'll stay after class for questions as well.
Oops, I don't want this.
No? Yeah. No, sorry, I didn't say that. On the information card that you'll fill out, you're going to put your preferences of the 7 projects. So we'll try to match people with their highest preference as well as balancing skill sets in the projects. Yeah, me, Michael, and the other 6 project mentors. Also, I brought the 4 books up here, which you can check out after class too, if you want to see them.
Question?
Yeah.
Do you fill out the cards in class, or?
No, you fill them out online after class. Yep, and we'll put the link up on Stellar, or it might already be up.
For the survey.
Yeah, well anyway, we'll put it up on Stellar after the next class. Okay. You want the mic?
All right. Do I need to? Am I being?
You're being taped.
Excellent.
And then indicted.
Excellent. Just add it to the list. Hello, everyone. Hi, Angie. I'm glad people already know me. Yay. For those of you who don't know me, I am the librarian for mechanical engineering. I'm also the librarian for material science. And I do a lot of instruction for classes like this, and I'm happy to help anyone with any type of question you have, whether or not it's related to mechanical engineering or this class. Amos just mentioned that you might actually be publishing your results. We can also help in the libraries with any copyright questions you have. Can you reuse these figures that you found in some other publication? Can you publish something in an open access journal so that more people can see it? We're happy to help you with that. And if you're doing any other type of research and you're collecting a lot of data, or if you're filling out grant proposals for large funding agencies like the DOE or NSF, we can also help advise you with those and what requirements you need to put in about what you're doing with your data and things like that. So we're not just about this class. Libraries are here to help you with anything.
By the way, it's most likely that you will publish something out of the class. We had 4 out of 6 of the teams publish their work.
Awesome.
And 2 of them, I think, are going to go on to journal papers in the next few months. So.
Which is great for you.
Yep.
So what I'm going to show you really quickly, since we don't have a whole ton of time, I could easily spend 2 or 3 hours telling you about all the stuff you might possibly use in this class, if not elsewhere in your lives. I'm not going to do that because we only have about 20 minutes. So I'm just going to show you a few quick places to go and a few quick tips that will make your lives easier both for this class and beyond. So if you haven't seen the library homepage yet, this is what it looks like. It can be kind of confusing, and there's so much information on the library's homepage, it can also be very overwhelming. So as you were shown on one of the slides that I just saw, there is a guide that I created just for this class. So you don't have to worry about figuring out, of all of these guides, which one do I go to for finding information about this village that I'm working with, or something like that. So there is a link to the class, so big. And you will have this direct URL on your Stellar page, and it was also just on the slides that you saw. And you know you're in the right place because there I am. Woohoo! And you know how to get in touch with me. You can also, if you don't want to get in touch with me directly and you have questions, you can always use our Ask Us service. We have a chat service, which you can see is online right now. We have an email service. You can stop in a library. You can call. That's usually the fastest way to get help, because who knows, tomorrow I might decide I need a 3-week vacation and I'll just disappear. And then you won't be able to get help because I will be gone. But if you use these services, then it'll be all fine. So this page is really intended to be a starting place for any of the projects that you'll be working on for this class. It isn't going to be everything you may ever possibly need, but you should at least be able to get started and be able to find some good information starting from this page. I'm going to start from the bottom. Actually, before I even start from the bottom, you'll see a box here to manage your references. How many of you already use some kind of citation management system like EndNote or Mendeley or Zotero? A bunch of you. Good. I'm going to quickly demonstrate Zotero just to show you how easy and how much easier your lives will be if you pick one of these tools. We don't really care which tool you use. Mendeley and Zotero are both free, and you can set up group accounts so you can all share citations within your team. With Mendeley, it's better at organizing the actual PDFs themselves. So if you want to share PDFs with your team and annotate them and say, hey, check this out or something, Mendeley's better at that. Zotero's a little better with actually citing once you are writing your papers that will then be published in amazing publications later on. So again, if you need help on any of those things, you can always contact me, or we have a team of librarians that can meet with you and walk you through how to use these tools. But I'll demonstrate Zotero because it's easy. But I'm going to start at the bottom of the page just to give you a sense for what's here, because it's kind of a long list. So at the very bottom, is a section just for handbooks and encyclopedias. This is a great place to get started if you're becoming familiar on a new topic. So if you are developing some kind of, one of the topics was lenses, I believe? Glasses? Vision assistance. So you might need to learn more about optics if you don't already know about optics. You can use one of our handbooks to get more of a basic understanding about that before you delve into then how do you solve the actual problem that you're trying to solve. Again, these are just like a sampling of all of the different types of handbooks or books that we have available. And I'm not going to go into searching them all, but you're all smart. If you see a box, you type something in it. You'll get results. And if you aren't finding the results you need, ask me. The next box up is really more to get data on a variety of things. So you might want to learn more about the company that you're working for or the organization that you're working for. You might need to learn more about the region that you're investigating or the type of maybe soil that that region has. For example, in IndiaStat or one of these tools, there's a lot of data on, like India road data. So maybe you need to find out like what percentage of the roads are paved. You can get a lot of that data using tools like this. Again, if you aren't finding what you need, ask and we will find it or help you find it. Okay, moving right along. As I said, I'm just glossing over all of this. Ask me questions. There are many databases that you can use to find articles. And it really depends on the subject matter of what you're researching, on where you're going to find those articles. So I listed a few of them here. Compendex and InSpec is where you're going to find articles on anything having to do with engineering in any type of field, engineering. Also, With InSpec, you're also searching anything having to do with physics, so that's all aspects of physics, or anything to do with electronics, computing, control, robotics, and those related fields. The good thing about Compendex and InSpec is they go back to literature from the late 1800s. So for some of your projects, you might not want the most recent, up-to-date, high-tech solution. You can look at some of the solutions that people used back before they had big power grids or something like that. A quick example I'm going to show you is in CAB Abstracts. CAB Abstracts is a database of literature having to do with environment and agriculture from all around the world. So it's a great place to get information from some of the developing countries, or not just like the United States or Europe. So the example I threw in here for one of your topics is cotton, and I put in cotton harvesting just to show you an example. So I'm actually going to make this a little smaller so you can see more. So one of the great things about the article databases we have is there are usually really good ways for you to narrow your results. So you can see there's almost 1,300 articles here, which you're not going to sort through. But we could go down here on the left-hand side, and you may want to limit by geography. So you might say, you know what, only show me the articles that have to do with cotton harvesting in India. And then you can take a look at some of these articles and determine if you think they're useful to your project or not. So if there is something you're interested in, you could always click on the link to see more about it. Anytime you see a button that says get this or get this MIT, you're going to want to click on it, because if we have access to that article electronically, it will take you to that article. If we don't have access electronically, it'll take you to a menu where you can either get it from our print collections somewhere on campus, or you can request it, and we'll figure out who in the world has it, and we'll have it delivered for you. So, okay, here's another, yes?
How long may it take for getting it from somewhere else?
It depends on what you are asking for from another library. For articles, it's usually pretty fast, because another library will just scan the PDF and send it. It's usually a day or two. If we have to have them mail a physical book, it can take longer. So it depends. So once you're doing your research and you find articles that you're interested in, now I'm going to show you quickly how easy Zotero is. So Zotero is a plugin on my browser. You can tell I have it because there's a big Z here. If I click on that Z, it's going to open my Zotero window down at the bottom. And you can see I have lots of different folders for all the research that I'm doing. And I do have a folder just for this class. So now I know I'm in that folder. And next to the Z is this folder icon. That's Zotero saying, hey, I think there are citations on this page. Do you want any of these citations? When I click on that, it gives me a list of all of the articles. And I could just say, why, yes, I would like this one, and this one, and this one. And you can see it's already saving them into my Zotero folder. So now I have those citations. I know where they are within my Zotero complex, and I can move on. Are there any questions about that?
Is it a plugin in Firefox?
It's a plugin on Firefox. It also works with Chrome and I think with Safari. When you go to the links on these guides, these all take you to pages that describe how to install, what it is, and how it works with whatever tools we have. I will point out about the SAE Digital Library. For those of you doing research on any of the automotive topics, SAE is a great resource, but they can be really annoying to find. We have all of the papers somewhere in the MIT libraries. It's just a matter of what format it's in. So if you get to the SAE Digital Library and you're looking for anything older than 1998, you won't be able to get to the PDF. But we will have it somewhere. So you could always just ask me and I'll say, oh yes, that's here. I'll figure out how to find it. Because it might be in microfiche, it might be in a book, it might be in a journal. They're all over the place. We do have them. We'll get it to you. It's just not a PDF yet. Someday. Maybe. Okay, are there questions about any of the things I quickly ran through right now before I talk about patents? No, excellent. So you'll notice along the side here is a link to a patents guide. This is similar to what I said about citation management tools. There are lots and lots of ways you can search for patents. I don't really care which way you use, whichever way works for you. Each tool or each interface has its strengths and weaknesses. I would say never search the USPTO if you can help it, because their interface is horrible and you don't get PDFs, you get TIFF images. Don't go to the USPTO. Any other option works great. If you look at where to search, we even have a little table of some of the different tools and what their strengths and weaknesses are. I'm going to show Google Patents really quickly. Google Patents keeps changing and evolving, and every time I search it, it's a slightly different, and it's getting better, which is why I'm showing it. I'm also showing it because everyone naturally just goes to Google Patents and doesn't bother with these other tools. If you really get into patent searching, I would recommend you try the database PatSnap, because there's a lot of ways you can analyze patent data and coordinate things in different ways that you can't do in Google Patents. But since, we all love Google, so for a patent search, I mean, you can search this the way you'd search anything else in Google. Just throw in some words. Like I said, you see a box, you put in words, you see what happens. So I'm going to look up the liquid, if I can spell this, desiccant. Now, one of the neat things that Google Patents just recently did, which I was very surprised by, normally when you search for patents, you put in words and you don't know where those words are coming up, and it's very confusing. And the way you want to search for patents is to really figure out what classification codes that patent falls under. Because the codes really describe what the device does, not the words that describe the device, if that makes sense. So if you can find the right codes, you're going to get everything. Like if you find the correct code for water filtration, you're going to get every type of device that does water filtration, whether or not they use the words water filtration in their description of their device. And since patents are written kind of vaguely into kind of obscure and cover everything and nothing at the same time, it can be good to just throw a broad net like that once you figure out what your categories are. So the good thing about Google Patents, which I just discovered, is they're starting to just put the actual classification codes in the search result right here. So we can see right here, this F24, F3, that's the classification code. And this is a description of the code itself. So in reading that, you might say, this is kind of what I was looking for, an alternative to air conditioning, but it's using this desiccant, is that how you say it? So when you see that, you'll be like, great, I want to get all the patents that fall in that code. And of course, if you click on the little question mark, that takes you into another patent database which just lays out what the code is if you're really interested in. So F is for mechanical engineering, F24 is for heating and ventilation, then it goes into air conditioning. So you can see the whole breakdown. So if you wanted to, you could say, oh wait, I just want everything having to do with air conditioning, and you could use that code instead. But if we go back to our results, I'm just going to take a look at one of these. Actually, what I'm first going to do is, if I look in the options, I want granted patents. So, and this is so pale. So I want the filing status to be granted. So I don't want to look at the applications. I only want to see what has been granted. And then you can look at the patent. There are lots of all the diagrams. You can see what other patents have cited this patent. So that's a way where you can also go forwards and backwards in time. So if you see a great patent, you can be like, what is this patent based on? And move backwards until maybe you can find a technology that isn't using all the bells and whistles that we use today. Okay. And in here, here's Zotero, here's my little thing. It doesn't know that it's a patent, but it's saving it. All right, are there any questions about? And we can, I can sit with you for, again, hours just talking about patents, but that's kind of a taste. All right. I'm now going to show you, so that pretty much covers like very basic things. Again, always ask questions. If you spend more than 15 or 20 minutes looking for something, stop and ask, because you shouldn't be spending your time digging through 100 pages of Google when you could be out in the field or actually making something. Stop what you're doing, contact us, let us help you. Never pay for information. If you're ever asked to pay for something, stop what you're doing. Contact me, contact the libraries, and we will get you to the information you need. So, last thing. You did all your research. Now you're writing your amazing paper for this class. As you can see, I really worked hard in this class. So, this is going to be published, I know. So now, I want to start inserting my citations. All you have to do with any of these tools, they all work the same way, it just depends on which tool you're using, how you do it. So, I know that I need to cite something here. I just put the cursor where I want the citation to go. For Zotero, you have a little plugin that goes in your add-ins, and that's what all these little symbols are. So the very first one is insert a citation. So I'm going to click on that. First thing it'll ask me, what citation style are you using? And you can talk to Amos about that or figure out like where are you going to be publishing this? Is it going to be at an ASME conference? You might want ASME style. So we'll just select that. So now it knows how the citation should be formatted. It's like, well, what did you want to put here? So here I could do a search, or if I click on the Z, I can see and go to the classic view. I'll see all my folders. So I can go to my 276 folder and say, haha, this is the citation I wanted. OK, and now it's inserted it. So I keep writing. Then I remember, oh, I forgot to cite something way in the beginning. Oh, I should start my whole paper over. No. You just go back to where you forgot to put your citation. Put the cursor there. Insert a citation. I'm going to say this one. And I'll just do it one more time. OK, so the end, because you should always end academic papers with the end in big letters and a smiley face, right? That's how you get published, right? OK, so once you're done, you again go up to this toolbar, find the little symbol that is inserting your bibliography. You click on that, and there's your bibliography. So you don't have to cut and paste. You don't have to remember, is the italics here, or do I underline? Always read through them, because sometimes Zotero might not grab all the information, or whatever tool you're using. You should always double check your citations. And one of the great things, too, so you're done with this class, and you're like, maybe the ASME conference wasn't the right one. I really think I should publish this in Science, because the research was that amazing. All you have to do is go back into your document. You look for the little gear, because little gears fix everything. You click on that, and then you can just choose a different style. So I guess I'll do Nature instead of Science. And it just reformats everything for you. So that's why we love these tools. Please use them. They will save your life. Don't write things on index cards like I used to have to, which was horrible. And that's all I had. And I'm early. Look at that. Are there any questions for me? Yes?
Are those tools free to use after we graduate?
Zotero and Mendeley are both free to anyone. Mendeley, we do have an MIT institutional subscription where we give you a lot more storage and the ability to set up a lot more group accounts. I don't know, they're both fairly new tools, and Mendeley having institutional access is relatively new too, so I don't know if they even figured out what to do when people leave, so I would say probably. You could definitely have the regular account, but yeah. Any other questions for me? No? All right.
All right, well, I'll see all of you on Monday, and I'll stick around for a while if you have questions for me. Go team.